Okay, so we're looking at question 3C from exercise 9N in the textbook. Okay, so let's just have a wee look at this and see if we can get to the bottom of it. So we're being asked to calculate the total area between the graph of the function, the x-axis and the given line, and what we've been given is y equals x bracket 3 minus x, and then we're asked about this between x equals minus 2 and x equals positive 2. So the first thing we need to do is draw the graph of the function y equals x times 3 minus x. Now, the x means it crosses the x-axis at 0, and the 3 minus x means it's going to cross the x-axis also at 3. So those are your roots, and that's going to be important. If we were to multiply that out, this is 3x minus x squared, so it's got a maximum turning point. It's a sad face graph, and it'll look a little bit like that, but obviously much smoother. Okay, and we're looking at this between minus 2, which is here, and 2, which would be roughly there. So we're looking to get two areas. We're looking to get this area here between minus 2 and 0, and then we're looking to get this area here between 0 and 2. So that means we're having to do two separate integrals, remember, because one will turn out negative and we'll need to make it positive. So we need to do the integral between minus 2 and 0 of x bracket 3 minus x. And then we need to do the integral between 0 and 2 of this same function. Now remember, in order to integrate this, you're going to have to multiply it out first of all. So we're integrating between minus 2 and 0, 3x minus x squared dx. Okay. Now the fortunate thing about when we do these questions is when we do the integration, obviously the integration in both these cases is going to be the same because we're integrating the same function, we're just looking at different limits. So when we integrate this, we're going to get 3x squared over 2 minus x cubed over 3, and we're looking at that between 0 and minus 2. And then this other one is obviously the same. And that's going to be between 0 and minus 2, and that's utter rubbish. Let me change that. That was the first set of limits that we've already talked about. This one is between 0 and 2. Okay, so if we're putting this in, we've got 3 times 0 squared over 2 minus 0 cubed over 3. That part's actually obviously going to give you 0. And then we're taking away 3 times minus 2 all squared over 2 minus 2 all cubed over 3. Okay, I'll do the other integral in a minute because I'm obviously going to run out of space here. Okay, so the first bracket gives me 0. The second bracket gives me 3 times minus 2 squared is 3 times 4, which is 12, and 12 divided by 2 is 6. And then negative 2 cubed is negative 8. So this is going to be take away negative 8 over 3. Okay, and taking away a negative obviously makes it a plus. So that is going to be 8 plus 6, plus 8 over 3. 8 over 3 is 2 and 2/3, so this is going to be minus 8 and 2/3, but we make it positive because we're looking at an area, so 8 and 2/3. For the other one, let me just get rid of this bit so that I've got a little bit of space, guys. Okay. For the other one here, we're working between 2 and 0, so we're putting in 2 first of all. 3 times 2 squared over 2 minus 2 cubed over 3. Subtract, when you substitute 0 into there, we've done it already today, that just gives you 0. So we're just working with the first bracket. So this is going to be 3 times 4 over 2, take away 8 over 3. Okay, 3 times 4 is 12, 12 divided by 2 is 6. So 6 take away 8 over 3, which is going to be 3 1/3. Okay, and then from there, adding those two together, the 8 and 2/3 plus the 3 1/3 is going to give you an answer of 12 square units. Okay, hopefully that helps. If not, let me know.